Hello, this video covers my first alum crystal growth update. My lab partners and I synthesized this alum solution in our Tuesday afternoon lab section earlier this week, approximately 72 hours ago from today. Before starting this video, I carefully tried to remove the rubber band and wipe from the top of the vial that I used to cover it while it was sitting, and I accidentally dropped the container. As a result, about half of my alum solution spilled out. As you can see, there's still solidified, dried up alum residue all over my refrigerator and desk that I need to continue cleaning up. I'll have to take this into account as an accidental error and mistake, which may obviously delay and hopefully not, but probably corrupt the growth of my crystal over the next 2 weeks. I'm hoping that nucleation will still be able to occur properly and allow for crystals to solidify. However, regardless of this, I will be able to compare my crystal product to my lab partners. Anyway, this alum solution was created through a series of 4 chemical reactions and various lab techniques, such as vacuum and gravity filtration and using a hot plate and magnetic stir rod. So, the first in the 4 series of reactions involves taking aluminum foil and adding potassium hydroxide, and as a result, aluminum hydroxide and hydrogen gas are produced. In the second reaction, we took the aluminum hydroxide and add sulfuric acid to neutralize and continue to break it down and produce new products, which are water, this aluminum compound, and hydrogen sulfates. In reaction 3, we took the aluminum compound again, and this time added the rest of the sulfuric acid that we were working with to produce water, aluminum ions, and more hydrogen sulfate. And then in the final reaction in this lab experiment, potassium, aluminum, and sulfate ions, along with water, were combined to produce alum. Sodium chloride can be produced in sort of a similar method, but without a bunch of complicated filtration techniques and with less steps, of course. And I actually did this experiment in my high school chemistry class. It's pretty simple. All you do is just boil salt water for about 5 minutes at the correct temperature, and then afterwards pour it into a jar and allow something such as a string or a pencil. In my high school course, we used pencils to suspend itself into the saltwater solution that you have, and over time, if you let it sit undisturbed for a while, sodium chloride crystals will begin to form around the pencil or string, whatever you use as surface area for the crystal growth foundation. Now, rock candy, which is a popular treat that's often sold like at amusement parks, can be made in sort of a similar fashion. I've never done this myself, but I've seen my sister do it, and according to Home Science Tools, it's a pretty simple process. It just involves boiling sugar water for the right amount of time, of course, depending on how much quantity you're using, and then adding food dye if you would like to, and suspending candy sticks inside of the solution that you leave in a jar, sort of similar to this process. And over time, sugar crystals will begin to form all over the candy sticks, and you're left with this nice, pretty looking rock candy.